Hello, this is lesson 4.1e, multiplying fractions. Okay, so we will be multiplying fractions. Today you're going to be able to multiply them. You'll be able to multiply fractions and whole numbers. You'll be able to multiply mixed numbers, and you will be able to estimate answers using rounding with fractions. We're still working in the same standard 6NS4. So let us begin, and I will minimize myself for full screen purpose. Multiplying fractions with fractions. So here's the good news. Fractions can be multiplied without needing the same denominator. So everything you did with adding and subtracting, having to find the same bottom number all the time before you could add or subtract, you do not have to do that with multiplying or dividing fractions. You don't have to worry about any of that. So you're going to find that multiplying fractions and dividing fractions is a lot easier. So when multiplying fractions, I always write them horizontally. When you add and subtract fractions, you're going to write them vertically, but not when you multiply or divide. Then write them horizontally. So we have 2/4 times 3/8. Notice how I'm going across instead of up and down. Now I don't have to worry that the 4 and the 8 are different. I do not have to worry about that. I just have to multiply across the top, the numerators, and multiply across the bottom, the denominators. So watch how this works. So we have 2 times 3 on the top and 4 times 8 on the bottom. So let's just do the math. 2 times 3 equals 6, and 4 times 8 equals 32. So 6 32s is my answer. However, remember we have to reduce. We still have to do that part. So we have to find the greatest common factor of 6 and 32. So let's reduce that fraction. So 632, the greatest common factor of 6 and 32 is going to be, I believe, 2. Yep, nothing bigger than 2 will go into both of those numbers. That is the biggest one that will go in. So 6 divided by 2 is equal to 3. And 32 divided by 2, now let's see, what if you don't know what 32 divided by 2 is? How could you figure it out? Besides using a calculator, right? Put 32 on the inside, put 2 on the outside, and divide. That's supposed to be a 2. 2 goes into 3 one time. 1 times 2 is 2. 3 minus 2 is 1. Bring down the 2. 2 goes into 12 6 times. 2 times 6 is 12. 12 minus 12 is 0. So 2 times 16 equals 32. So 32 divided by 2 is going to be 16. So let's bring that one up. And that's in lowest terms. So that is our answer. So 2/4 times 3/8 equals 316 in lowest terms. Okay, let's look at another example. There is a shortcut. So I'm going to show you the shortcut, and you're going to want to use the shortcut because you won't have to reduce such big fractions. So let's see the same problem again. We can use canceling as a shortcut to reducing a fraction. So you're going to want to do this. You're going to like this method. So here's the original problem we had in the previous screen. 2/4 times 3/8 equals 6 over 32. And then we reduced it by dividing by 2, and we got 3/16 here. Here is the shortcut. We're not going to do this part. We're not going to have to do this part. And finally, we're not going to have to reduce. We're going to do the reducing as we go. Watch how this works. So let's do the original problem again. 2/4 times 3/8. So we're going to look, and we can do anything above or below. So we can cancel something that's above or below. So let's take a look. So I'm going to cancel the 2 and the 8 because I'm going to divide 2 by itself with a 2, and I'm going to divide 8 by the same 2. You have to divide by the same number. So I'm dividing both 2 and 8 by 2. What is 2 divided by 2 going to give me? 1. And what is 8 divided by 2 going to give me? 4. There we go. I wish that black bar would go away. Should in a moment. There it goes. And I can't cancel anything further, so I'm done. So now I just do multiply the numerators, multiply the denominators. So I have 1 times 3 on the top now instead of 2 times 3. And I have 4 times 4 on the bottom instead of 4 times 8 because I canceled. So now I just do the math. 1 times 3 is 3 and 4 times 4 is 16. Notice how I got the same 3/16 that I got before, only this time I had less work to do. So I'm going to show you that method again. So canceling allows you to eliminate the step of reducing. Yay! Okay, here we go, seeing it again. So we're going to write them horizontally. 1/3 times 3/5. First, I'm going to show you the regular method, then I'm going to show you the canceling method. So you're going to multiply the numerators and multiply the denominators. So you're going to do 1 times 3 on the top and 3 times 5 on the bottom. And then you're going to do the math. So 1 times 3 equals 3, and 3 times 5 equals 15. Notice how 3/15 though is not in lowest terms. It needs to be reduced. So we're going to take 3/15. What's the greatest common factor of 3 and 15? Did you say 3? Then you are correct. So we're going to divide 3 divided by 3 is equal to 1, and 15 divided by 3 is equal to 5. So the answer is 1/5. Okay, let's see it with the canceling method. Okay, there's our original problem, and we just figured out it was 1/5. So let's redo it using canceling. We're going to not have to do that step. We're going to not have to do that step, and we're not going to reduce. So 1/3 times 3/5. So is there anything I can cancel in that problem? Exactly, I can cancel the 2 3's, right? Because 3 divided by 3 is 1. So I'm going to cross off my 3's and write a 1 by each 3 because 3 divided by itself is 1. Now I just multiply across the top and across the bottom. So instead of 1 times 3 on top, I have 1 times 1 on top. And instead of 3 times 5 on the bottom, I have 1 times 5 on the bottom. And then I multiply. 1 times 1 is 1, and 1 times 5 is 5. Here's my answer. Notice it's the same as when we did it the first method. So canceling is a great way to reduce your steps. Okay, let's go on. 7/24 times 3/14. Multiply the numerators, multiply the denominators. Okay, 7 times 3 on top, 24 times 14 on the bottom. Notice how my numbers are getting bigger. So I'm going to want to use the canceling method. I'm not going to yet. I'm going to show it to you the first way, and then I'm going to show you the canceling method and how much better it is. So 3 times 7 should be 21. And what's 24 times 14? See, the numbers are getting a lot bigger. So if I don't know what that is, I got to do the math now, right? I got to do 24 times 14 and multiply, right? So 4 times 4 is 16. Carry my 1. 2 times 4 is 8 plus 1 is 9. Now I go to the next column. I'm going to go underneath the 1. 1 times 4 is 4. And 1 times 2 is 2. And then I'm going to add those together. And I'm going to get 6. 9 plus 4 is 13. Carry the 1. 2 plus 1 is 3. So that answer is 336. So it's going to be quite a big number. So let's see what happens. Okay, so we have 21 over 336. Now we have to reduce this great big number. Gets harder now when you have these big numbers, especially with multiplying. You can get some pretty big numbers. So what can I divide both by? I have to figure out the greatest common factor of 21 and 336. That's not that easy to do, is it? So I happen to know that it is 21, but you may not know that. You could start with dividing by 3, and then you'd probably have to divide by 7. But I just know that 21 divides evenly into 336. So I figured it out. I could list all of the factors of 21 and all of the factors of 336 and find the two matching ones, and it would be 21. So, in the sake of time, I've already shown in previous videos how to do greatest common factor. So go back and watch those videos if you need to know how to do that. However, just know that it's 21. So 21 divided by 21 is going to be 1. 336 divided by 21. Okay, I'm stuck now, right? Okay, so I have to go 336 divided by 21. That's a big number, right? So 21 will go into 33 one time. 1 times 21 is 21. 33 minus 21 is 3 minus 1 is 2. 3 minus 2 is 1. There's 12. Now I have to bring down my 6. And I have to figure out how many 21s go into 126. Well, let's try 6. Because our number ends with a 6, so I'm going to try a 6. 1 times 6 is 6. 2 times 6 is 12. There's 126. So it's going to be a 6. And then 6 times 21 is 126. 126 minus 126 is 0. So 336 divided by 21 equals 16. So that's what we're going to put there. Notice all the work you have to do now, right? So the final answer is 1/16. Okay, now we're going to show you the canceling method. It'll make it so much easier. So here was our original way. We had 21 over 336, and then we divided by 21 over 21 and got 1/16. Now let's redo it with the canceling method. We're not going to have to do that, or that. Okay, 7 24s times 3 14ths. Can I cancel anything? Exactly, I can cancel the 7 into the 14 and the 3 into the 24. So let's do the 3 into the 24. So if I divide 3 by itself and I divide 24 also by 3, I'm going to get 8 on the bottom there. 24 divided by 3 is 8, and 3 divided by 3 is 1. Then I'm going to do the other two numbers. So 7 will go into 14 twice, and 7 will go into itself once. So notice how I've done that. And now I just multiply across the top, the numerators, and multiply the denominators. This time I only have 1 times 1 on top, and I have 8 times 2 on the bottom. Super easy. 1 times 1 is 1, and 8 times 2 is 16. I get the same answer as I got with the other method, with a lot less work. Okay, let's keep going. So remember, canceling helps you to not have to reduce big numbers. Okay, 8 21s times 1/3. Times, another one, 15 over 32. Now, if I were not using the canceling method for this, I would get some really big fraction that has to be reduced. I'd have to multiply 8 times 1 times 15 on top, 21 times 3 times 32 on the bottom. That's a lot of work. Luckily, I know how to cancel. So I can notice that 8 and 32 will cancel nicely. 15 and 3 will also cancel nicely. So let's see how that works. So let's cross off the 8 and the 32. So I can divide 8 into 32. How many times will 8 go into 32? 4 times. And then 8 into itself will go once. So I will change my 32 to a 4 and my 8 to a 1. Okay, now I'm going to do the 3 and 15. 15 divides by 3 nice and evenly, and 3 divides by 3 nice and evenly. So 15 divided by 3 is 5, and 3 divided by itself is 1. Is there anything else I can cancel, or am I done? I am done. So I'm going to write my new numbers. 1 times 5 on top. 21 times 1 times 4 on the bottom. So now I'm left with a lot less of a big number. All I have to really worry about is multiplying 21 times the 4. So that's not too hard of math. 4 times 1 is 4, and 2 times 4 is 8. So that's going to give me 84. So my top number is going to be a 5, 1 times 1 times 5, and my bottom number is going to be an 84. So now I don't have to reduce that fraction. I've already done it over here with my canceling. So my answer is 5 over 84. Yay! See how much easier that can be for you? Let's do another one. 15 28 times 7 16ths. So I'm going to, and there's one more, times 12 45. So I'm going to tell you to pause the video, try this method, try the canceling method, and then press play and see if you got it right. Okay, I see some things I can cancel. The 15 will divide evenly into the 45. I can divide a 4 into 12 and 16, and I can divide the 7 into the 28. So I got lots of stuff I can do here. So let's see. Let's start with the big one, 15 and 45. If you don't know how many times 15 goes into 45, just think about, well, 15 plus 15 is 30, plus another 15 would be 45. So it's going to be 15 times 3. Just proving it to you there. So 45, right? So 15 will go into 45 3 times, and 15 goes into itself once. Okay, now I can do 28 and 7. 28 divides by 7 nice and evenly into 4, and 7 divides into itself, we get a 1. Now I have 12 and 16. Cross them off. 12 divided by 4 is 3, and 16 divided by 4 is 4. Now there's one more thing I can do. Notice how I have a 3 over 3. I can cross those off as well. So 3 divided by 3 is 1, and 3 divided by 3 is 1. So look how much simpler I made that problem. Otherwise, I'd have huge numbers to multiply together, right? So now I just have to multiply 1 times 1 times 1 on top, and 4 times 4 times 1 on the bottom. Super easy. What's 1 times 1 times 1? Well, that's going to be 1. And 4 times 4 times 1 is 16, right? So there's our 1/16. Okay, now it's your turn. Give this a try. See you back in a moment. Okay, welcome back. Hopefully you did your problems. You're doing them in order on your Google form with the video so that you got it fresh in your mind when you do the questions. Okay, now we're going to work with multiplying fractions with whole numbers. So we have 1/6 times a whole number, 11. Okay, we can do this. What do? Well, we rewrite the 1/6 times, and we change the 11 to 11 over a 1. Because we know we haven't changed the number, because 11 divided by 1 is just 11. So we're not changing the number at all. We're just putting it over 1. So we have a fraction times a fraction. So can we cancel anything? Doesn't look like 6 will go into 11. So we just have to multiply across the top, 1 times 11, and across the bottom, 6 times 1. Notice how we're going to get 11 over 6. There's a problem. 11 over 6 is an improper fraction. So remember what we did with adding and subtracting when we ended up with an improper fraction. So we divide and convert it to a mixed number. So we're going to put which number on the inside, 11 or 6? Yes, 11 goes on the inside, 6 goes on the outside. Now I divide. How many 6s go into 11 without going over? Well, 6 times 1 is 6, 6 times 2 is 12. Oops, I'm over. Can't go over, so it has to be a 1. I'm going to put the 1 over the second one because I went into the whole number 11. So now I multiply. 6 times 1 is 6, and now I subtract. 11 minus 6 is 5. Now what am I going to do with my remainder down here of 5? What can I do with that? Well, I'm going to bring it up to the top. It's going to become my numerator. My bottom number is going to stay a 6, just like you learned in adding and subtracting. So my final answer is 1 5/6. Let's see that again. Whenever you multiply by a whole number, you're probably going to get an improper fraction. So 4/9 times the whole number 18. First step, rewrite 4/9, change the 18 to 18 over 1. So I have a fraction multiplied by a fraction. Now notice how I can cancel, because 9 goes into 18. So because I noticed that, I'm going to do that. So I'm going to cross that off. 18 divided by 9 is 2, and 9 divided by itself is 1. So I'll get 4 times 2 on top, and 1 times 1 on the bottom. Super easy. 4 times 2 is 8. 1 times 1 is 1. 8 over 1 is the same as 8 divided by 1, which is just 8. So my answer is 8. Okay, we didn't have to do any dividing to make a mixed number on that one, so that was nice. Let's try 7/12 times 36. Okay, so we're going to rewrite that as 7/12 times 36 over 1. Okay, now notice how 12 will divide into 36, so I'm going to do that. I'm going to cross those off, and 36 divided by 12 is 3, and 12 divided by itself is 1. So now I multiply across the top, 7 times 3. I multiply across the bottom, 1 times 1, and then I do the math. So 7 times 3 is 21, and 1 times 1 is 1. 21 over 1 is just 21. Yay! See how easy this can be? It's so much nicer than adding and subtracting. I think you'll agree with me on that. Okay, you get to try this. We will see you back after you multiply some fractions with whole numbers. Okay, welcome back. We are now going to multiply fractions, it says, with whole numbers again. Okay, why did I say that? Let's see. Oh, it should say with mixed numbers. Multiply fractions with mixed numbers. I'll have to change that on the screen. Okay, so 3 3/4 times 4 4/9. Okay, how do we do this? Well, we first have to change our fraction into improper. So before you can multiply mixed numbers, you have to first turn the mixed number into an improper fraction. So how do I turn a mixed number into an improper fraction? Well, it's the whole number times the bottom plus the top. So remember the song. Whole number times the bottom plus the top, clap, clap. Whole number times the bottom plus the top, clap, clap. Whole number times the bottom plus the top, clap, clap. So we're going to do 3 times 4, which is 12, right? And then we're going to add that 12. We're going to add 3 more. 13, 14, 15, right? So and the 4 is going to stay at 4 on the bottom. So let's see how that works. So that'll be 3 times 4 plus 3, 15, and then the 4 stays on the bottom. How about this one? What's that going to be? 4 times 9 plus 4. Whole number times the bottom plus the top, click, click. So 4 times 9, 36, plus 4. 40, right? 40 over 9. Make sure you keep the 9. And now we're ready to multiply just like we normally would. So I noticed that I can cancel a 4 into 40 and into itself, and I can cancel a 3 into both of these. So I'm going to do that. So I don't have as big of numbers, right? So I'm going to divide a 3 into 15 and a 3 into the 9. 15 divided by 3 is 5, and 9 divided by 3 is 3. Now I'm going to do the 4 and 40. 40 divided by 4 is 10, and 4 divided by itself is 1. Now I multiply across the top, 5 times 10, and across the bottom, 1 times 3. So I get 5 times 10 is 50, and 1 times 3 is 3. Okay, so I do have to make this, convert this back to a mixed number now, so I have to divide. What goes on the inside? 50. What goes on the outside? 3. How many 3's go into 5? The first number there, 1, right? So I'm going to put the 1 over the 5, and I'm going to multiply. 1 times 3 is 3. 5 minus 3 is 2. And now I'm going to bring down my 0 and say how many 3's go into 20? Without going over, right? So 3 times 5 is 15. Can I get closer? 3 times 6 is 18. That's pretty close, but what's 3 times 7? That's 21. That's over, right? So I have to use 6. 3 times 6 is 18. 20 minus 18 is 2. What do I do with my remainder? I'm going to bring it up to the top. The 2 is going to become my numerator. My bottom number is going to stay a 3. So my answer is 16 2/3. Yay! Okay, try it again. Multiplying fractions with multiplying mixed numbers. That's what it should say. I'll fix that. 5 and 5/6 times 1 13/20. Okay, first step. I have to change my mixed numbers into an improper fraction. How do I do that? Whole number times the bottom plus the top. Click, click. Okay, let's see 5 and 5/6. Pause the video, see if you can figure out what 5 and 5/6 is an improper fraction, and what 1 13/20 is an improper fraction. And then press play and see if you got it right. Okay, so 5 times 6 is 30, plus 5 is 35/6. The next one is 1 times 20 is 20, plus 13 more, 33, right? And 20 stays on the bottom. Now, if I can cancel anything over here, I'm going to. And I see that I can take a 5 into both 35 and 20, and I can take a 3 into both 6 and 33. So I'm going to do that. So taking 35 divided by 5 is going to give me 7, and 20 divided by the same 5 is going to give me 4. Here I'm dividing by 3. So 33 divided by 3 is 11, and 6 divided by 3 is 2. And now I can multiply across the top. 7 times 11, and across the bottom 2 times 4. That's going to give me 77/8. Again, I have to change it back to a mixed number. So 77 on the inside, 8 on the outside. How many 8s go into 77? 9, right? 9 times 8 is 72. I subtract. I get 5 as my remainder. What do I do with my remainder? I bring it up to the top, and my bottom number stays an 8. So my answer is 9 5/8. Okay, you get to try some mixed number multiplication. Okay, welcome back. Hopefully you did those problems before you just kept playing the video. And let's continue. Now we're going to talk about estimating with fractions and multiplying. That title is correct. You can round fractions to get a general estimate of what the actual answer will be before you figure out the actual answer. This is helpful because then when you do find the actual answer, you can compare it to your estimate, and if it's way off, you know you've done something wrong. So estimating is a great way to quickly do something in your head to see how close to the actual answer you can maybe be. So here's a word problem. A class has 18 students. The teacher asks how many students in the class have pets. She finds that 5/9 of the students have pets. How many students have pets? Well, whenever you have this kind of problem, when you want to know a fractional part of a number, it's going to be multiplication. So we are going to first estimate. So 5/9 is close to 1/2, wouldn't you say? Because what is half of 9? 4.5, right? A little over 4, so 4.5 is actually exactly half of 9. So if the real number is 5/9, 5 is a little bit more than 4.5, so it's very close to 1/2. So we are going to multiply 1/2 times 18. So we know when we multiply 1/2 times 18, it's really the same as saying half of 18, isn't it? So that's about what it is. So half of 18 is really easy, right in your head. You can just do half of 18, which is 9, right? So 5/9 is close to 1/2, so multiply 18 times 1/2, which is going to give you 9. So the real answer that we get should be close to 9. Let's do the real answer now. 5/9 times 18. Well, what do we have to do? Well, we have to rewrite 5/9 and put the 18 over 1. Now I see that I can cancel the 9 and the 18, so I'm going to do that. 9 goes into 18 twice, and 9 goes into itself once. I'm going to multiply across the top. 5 times 2 and across the bottom 1 times 1. So 5 times 2 is 10. 1 times 1 is 1. 10 over 1 is the same as 10. There is my actual answer. Notice that it's very close to my estimated answer of 9. So that's what estimating is good for. If I would have gotten some other number than 10, let's say I got some weird number like 20, I'd be like, whoa, that's way off from my estimate. So I know I would have done some multiplication error on my exact. So that's what estimating is good to help you do. Let's do another one. 1 yard of lumber costs $2. What is the cost of 5 3/4 yards of lumber? So we're going to estimate first. I just want to show you that 3/4, so what is exactly half of 4? 2/4, right? So 2/4 is exactly half. Well, 3 is bigger than the 2, so 3/4 is going to be closer to 1. 3/4 is closer to 1 than to 0. So I'm going to round 3/4 up to 1. So now this 5 is 5 3/4 because it's really a 5 3/4. 5 3/4 is going to be closer to what number? Type that out here. So 5 3/4 is closer to which number? 5 or 6? Is closer to 6 because the 3/4 is bigger than half. So we're going to round up. If the number, the fraction part, is bigger than half, we're going to round the whole number up. So 5 3/4 is closer to 6 than to 5. Okay? All right, I'm going to clear that and let's see that. So we have 3/4 is close to 1 whole, so round 5 3/4 up to 6. So about 6 yards of lumber times $2 for each yard is about a cost of $12 for the lumber. 6 times 2, $12. So real easy to do in your head. Now when we get the exact answer, it should be close to $12 if we don't do any math mistakes. So 5 3/4 times $2. We're going to change 5 3/4 to an improper fraction. Whole number times the bottom plus the top. 5 times 4 is 20 plus 3 is 23, and then it stays a 4 on the bottom. We're going to times that by 2, and we're going to put the 2 over a 1, so we have a fraction times a fraction. I noticed that I can cancel the 4 and the 2, so I'm going to do that. 4 divided by 2 is 2, and 2 divided by 2 is 1. So now I'm going to multiply 23 times 1 on the top and 2 times 1 on the bottom. That's going to give me 23 over 2. Now I have to divide 23 on top, I mean on the inside, 2 on the outside. 2 will go into 2 at least once. So I'm going to put the 1 over the 2. So 1 times 2 is 2. I subtract. 2 minus 2 is 0. Bring down my 3. 2 goes into 3 one time. 2 times 1 is 2. 3 minus 2 is 1. I'm going to bring that up and make that my numerator. And 2 stays my denominator. So $11.50. How much will it cost? $11.50. $11.50 is very close to $12, our estimate. So we know we did our math correctly. Okay, another one. Robert works at a job and makes $15 an hour. How much does Robert make for 3 1/4 hours of work? Well, I look at the 1/4 here and I say, is that closer to the 3 or is it going to be closer to 4? Well, 1/4 is going to be less than half because 2/4 is exactly half of 4. So 1/4 is less. So if the number is less than 1/4, I'm not going to round my whole number 3 up. I'm going to keep it a 3. So I'm just going to round this number to 3. So 1/4 is closer to 0. So Robert, he works about 3 hours. So 3 1/4 has been rounded down to 3. About 3 hours of work times $15 an hour is going to be 15 times 3, which I can do pretty easily. That becomes $45. So he should make about $45. Let's see if our actual answer is close to that. So 3 1/4 times $15 an hour. First, we change 3 1/4 to an improper fraction. Whole number 3 times the bottom plus the top. 13/4. And then I'm going to put the 15 over a 1. Now, is there anything I can cancel in this? No, because 4 and 15 don't cancel by anything, do they? 13 and 1 certainly don't. So we do have to do bigger math on this problem. 13 times 15 and 4 times 1. Well, let's do the 13 times the 15 here. 13 times 15. 3 times 5 is 15. I'm going to carry my 1. 5 times 1 is 5 plus 1 is 6. 1 times 3 is 3. And then 1 times 1 is 1. And I'm going to add that up. And I'm going to get 5. 6 plus 3 is 9. And 1 plus nothing is 1. So 195 will be my top number. So 195, and then 4 times 1 on the bottom is just 4. Now I have to do a big division problem, right? 195 divided by 4. So 4 will go into not 1, but 19. So I'm going to start my answer over the 9. How close can I get to 19 without going over? 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. 5 is over, so 4 times 4. 4 times 4 is 16. I subtract. 19 minus 16 is 3. I bring down my 5. How many 4s will go into 35? Well, 4 times 7 is 28. 4 times 8 is 32. 4 times 9 is 36. 36 is over, so 4 times 8. 4 times 8 is 32. 35 minus 32 is going to give me 3. And now I could put that 3 up and make it a fraction, like I did in the last problem, but because it's money, I'm going to this time show you what to do to make it into dollars and cents. So I'm going to add a decimal point and a 0 up here. I can do that because 195 is the same as 195.0. I have not changed my number. That way I can bring down a 0, and now I have 30. So how many 4s go into 30? Well, 7, right? So I'm going to put my decimal point right up here, and then I'm going to put my 7. So 4 times 7 is 28. 30 minus 28 is 2. And I can add another 0. I can keep adding a whole bunch of zeros if I want, right? 195.0000000 whatever is still 195. So I'm adding another 0 and bringing it down. Now I have 20. How many 4s go into 20? Well, a nice even 5, right? 4 times 5 is 20. I subtract. And now I don't have a remainder. So I have, instead of making it 48 3/4, I made it 48.75. So that's $48.75. So that's my real answer. Is it close to my estimate of $45? Yes, it is. So I know I did my math correctly. Yay. Okay, you get to try some of these problems with estimating, and I'll see you back in a moment. Okay, last part, we're going to focus on some higher order thinking. So it's pretty much the same as what we've been doing. Kate wants to buy a new bicycle from a sporting goods store. The bicycle she wants normally sells for $360. The store has a sale where all bicycles cost 5/6 of the regular price. What is the sale price of the bicycle? So whenever you see something with an amount of money and a fraction, it's going to be multiplying. So we're going to multiply. Oops, I already told you. Are we going to add, subtract, multiply, or divide? Well, we're going to multiply. So always use multiplying when you are trying to find a fractional part of something like a price. Okay, so 5/6 times 360. We're going to rewrite that as 5/6 times, 360 over 1. I notice that I can cancel a 6 into this 360 nice and easily, right? Easily. So 6 will go into 36 6 times, and then there'll be a 0, so it's going to be 60. So 60 for that and 1 for the 6, and then I multiply 5 times 60 on top and 1 times 1 on the bottom. Well, if I don't know what 5 times 60 is, I can just multiply on the side of my paper so that I am getting the correct answer. So 5 times 0 is 0, and 5 times 6 is 30. Easy peasy, 300, right? So that'll be my top number. 300, and the bottom is just a 1. So 300 over 1 is equal to 300. So what is the sales price of the bicycle? $300. Yay! Okay, your homework will be on Google Classroom, and it's going to be a bigger packet, so I'm going to give you a few extra days to get it done. Don't wait till the last minute to do it, because you will have too much work. I believe there are 45 problems in the packet. So if you want to do half of them one day and half of them the next day, that would be my advice. But I will give you a couple extra days to finish it. But don't try to do 45 problems all at the last minute. So have a good day. Bye.